In this topic, we are going to look at the chords of a circle. Let's recap. What do you call a line segment that cuts through the center of the circle and connects 2 points on the circumference like this? Yes, this is the diameter of a circle. These are another 2 examples of the diameter of a circle. Now, what do you call a line segment that cuts through the center of the circle and connects to a point on the circumference? Yes, this is the radius. In plural, we call this the radii. And we have another 2 examples of radius. And what do you call a line segment that connects 2 points on the circumference but does not cut the center of the circle? For example, VE. This is called the chord. To note, a chord is always shorter than the diameter of a circle. And what is the name of the line DFE that is part of the circumference of a circle? This is an minor arc. And what do you call the line DGE that is part of the circumference of the circle? And this is the major arc. Now, what is the name of the region bounded by the arc DGE and the chord DE, indicated by the dark brown region here? This is called the major segment. And what do you call the region that is bounded by the arc DFE and the chord DE here? Yes, this is the minor segment. Here we have a chord DE and we measure it to be 13 centimeters. We locate the center of this chord here and we draw a perpendicular line that cuts through the center of the chord. And we notice that the perpendicular bisector of this chord here passes through the center of the circle. To recap, the perpendicular bisector of the chord DE means that it is a 90 degrees line that cuts the chord DE into half. And this 90 degrees line that cuts the chord DE in half passes through the center of the circle. And we call this property the perpendicular bisector of a chord. Now we can use the property the perpendicular bisector of a chord to help us to locate the center of a circle. We shall now first construct the perpendicular bisector of the chord PQ. And next, let us construct the perpendicular bisector of the chord PR. Since the perpendicular bisector of the chords will pass through the center of the circle, the intersections of these 2 perpendicular bisectors will be the center of the circle. Next, let's say we have a chord DE here, and we draw a perpendicular line that cuts through the center of the circle and the chord DE. And using a ruler, we notice that the 90 degrees line that's cut through the center of the circle also cuts through the chords in half. In another word, the perpendicular from the center of the circle to the chord bisects the chord. And we call this property the perpendicular from center bisects chord. Now let's look at some examples. In the diagram, O is the center of the circle and we have chord PQ, whereby PX is equals to QX, which is equals to 8 centimeters, and OQ, which is also the radius, is 10 centimeters. We are asked to find the length of OX. Now we know that angle OXQ is actually 90 degrees because of the property perpendicular bisector of a chord. This property states that if we draw a line from the center of the circle to the center of the chord PQ, this line will bisect the chord PQ at 90 degrees. And since now we have a right angle triangle OXQ here, we can use Pythagoras theorem. And the value of c squared here will be 10 squared. And on the right hand side we have OX squared plus 8 squared. To find OX, we will subtract 8 squared on both sides, which will give us OX squared equals to 36. To find OX, we will square root on both sides to give us OX equals to 6 centimeters. Next, let's look at another example. In the diagram, we have O as the center of the circle with two different chords AB and CD. Now, if the length of OX is equals to 6 centimeters, the length of the chord AB is also equals to 6 centimeters. If angle OAB is twice the angle OCD, how do we find the length CD? First, we know that the length AX is actually equals to 3 centimeters because of the property perpendicular from center bisects chord. Now, this property states that if we have a perpendicular from the center to the chord, this perpendicular will cut the chord into half, and hence AX will be equals to 3 centimeters. In order to find the length CD, we will need to know the radius and the angle OCD here. To do so, we will make use of the triangle OAX because we have the opposite and the adjacent length here. Now, using the tangent trigonometry ratio, we have tangent angle OAB is equals to opposite, which is 6 centimeters, over the adjacent, which is 3 centimeters. In order to find angle OAB, we will inverse tangent on both sides. And we have angle OAB equals to 63.43 degrees. Since angle OAB is twice angle OCD, to find angle OCD, we will need to divide angle OAB into half. And angle OCD is equals to 31.715 degrees. Since we have angle OCD, we shall now find the radius of the circle, which is OA. To do so, we shall use Pythagoras theorem, r squared equals to 6 squared plus 3 squared. And we have r squared equals to 45. Square root on both sides, we have r equals to 6.7082 centimeters. Now that we have angle OCD and the radius OC, we can now find CD by first finding the length of CY. With the given angle OCD here, CY will be the adjacent side and the radius OC will be the hypotenuse. And hence we will use the cosine trigonometry ratio. And we'll have cosine 31.715 equals to CY over the hypotenuse 6.7082. To find CY, we shall multiply 6.7082 on both sides. And we will have CY equals to 5.706 centimeters. To find CD, we simply need to multiply CY by 2, and we will have CD equals to 11.4 centimeters, rounded off to 3 significant figures. Now we know that CD is twice the length of CY because the perpendicular from the center bisects the chord. In summary, the property perpendicular bisector of a chord means that if we have a 90 degrees line cutting through the center of the chord AB, this 90 degrees line will pass through the center of the circle. Next, the property of perpendicular from center bisects chord means that if we have a 90 degrees line from the center of the circle to the chord AB, this 90 degrees line will cut the chord AB into half. And once again, perpendicular means 90 degrees and bisects mean cuts into half. And that's all for this part of the topic.